I'm Raphael Cassier. I'm chair of the South German section of the Audio Engineering Society, and it's my pleasure to welcome you all to this event, which is entitled Soundscapes, a brief history and exploration of concepts and applications in real-world projects. And it's going to be presented by Keely Siebein from Siebein Acoustics. Thanks for joining us. Keely has over 21 years experience in architectural and environmental acoustics and has worked on nearly 400 projects worldwide. She has edited and co-authored several books, book chapters, and journal articles. She is passionate about sustainable buildings and is president of the Florida chapter of the ASA, it's Acoustical Society of America, a member of the Acoustic Society of America, a member of the Institute of Noise Control Engineers, and a friend of the AES South Germany section. So welcome, and the floor is yours. Thanks.
Thank you so much for the introduction, Raphael. I really appreciate it. Let me first share my screen. Well, so as Raphael mentioned, my name's Keely Siebein. I am an acoustic consultant. So that means I design buildings and the environment with regard to sound, how sounds are meant to be heard. So try to design the soundscape of each of the projects that we work on. And so in some discussions with Raphael, he had mentioned the idea of soundscapes. And, you know, I'm sure the term may or may not be familiar to you and may or may not have some kind of meaning for you. But we're going to look at kind of the origins of the term soundscape. We're going to look at Murray Schafer and some of his works. And how he defined soundscape. And we're going to look at some of the principles that he identified and see how they have kind of filtered through and how we use some of these concepts and techniques in our soundscape studies in the projects that we work on. And so it just kind of gives you a little brief intro. This material is copyrighted. So I want to give you a little bit of a bio on Murray Schafer. Murray Schafer was born July 18th in 1933. He was a Canadian composer. He was a writer, a music educator, and an environmentalist. He's very well known for his World Soundscape project that we'll talk about in just a couple minutes. He's also been a passionate advocate for acoustic ecology and authored a very famous book, famous in my world and potentially your world as well, called Soundscapes. And he started soundscape studies at Simon Fraser University in Canada in the 1960s. And in 2010, a World Listening Day was organized by the World Listening Project, and it now takes place each year on July 18th to honor Murray Schafer's birthday. So he was a very, very prolific composer of stage works, orchestra music, soloist music, chamber music, choir music, vocal, and others, and he actually authored 28 books. The World Soundscape Project was one of his most famous projects. It was basically an educational and research group that he founded in the late 1960s to the early 1970s. And he actually taught a course in noise pollution at Simon Fraser University. And so as a result of teaching that course, this idea and project kind of came about. And so throughout this project, they published numerous little books and publications, and he, along with a group of very motivated young people, students and young composers that you can see pictured here, went all around. At first, they started out in Vancouver, and they did soundscape studies in that area, published the Vancouver Soundscape. Also ended up going across Canada on a recording tour with Bruce Davis and Peter Hughes. And the recordings from that formed the basis of the Soundscapes of Canada radio series. In 1975, he actually led a really interesting exploration to Europe, where their consortium got to experience lectures and workshops in some major cities, and also investigated the soundscape of 5 villages, one in Sweden, Germany, Italy, France, and Scotland. And, to kind of conclude this project, they compiled over 300 tapes at the time, and produced a couple publications as well. And the Murray Schafer's seminal book, The Tuning of the World, was published in 1977. It kind of came out of this. Barry Truax is one of Murray Schafer's colleagues, and he also has written very important books. One of those is called Acoustic Communication. And these books and these works are, at the core of the kind of philosophical framework of many of the projects that we work on. Excuse me. And so this World Soundscape project is very interesting. They do have a link to, and they have a website still with links to all of the information that you could think of, to the recordings. And so if anyone is interested in that, you can check it out online. You can actually email Barry Schafer and ask for access to the website, and he will provide it to you. That takes us to the soundscape, our sonic environment, and the tuning of the world. This is Murray Schafer's very famous book. It's influenced so many people, from musicians to acoustic consultants and designers like myself, and possibly even you audio engineers. And so we're going to kind of go through the book a little bit and talk about some of the major concepts. He broke the book into several parts. So the first part talks about this idea of first soundscapes, of natural soundscapes. So looking at the sounds of water, wind, land, unique tones, apocalyptic sounds, which was interesting, the sounds of the world being born, the sounds of what the world might sound like if it's destroyed. And this picture here shows the sound radius from when Krakatoa's caldera exploded. Sounds were apparently heard over 4,500 kilometers away on the island of Rodriguez. So incredible sound that was actually documented. Sounds of life. He goes into incredible detail about birds. He's very fascinated with birds, and lots of discussion about bird sounds and how to notate them, insects, water creatures, whales and crustaceans and animals. And he looks at the types of sounds that these species make, whether it's warning sounds or mating sounds, the sounds of mother and offspring, food sources, social sounds. And he says that man echoes the soundscape in speech and music, which is pretty interesting. With rural soundscapes, he looks at the sounds of pastures, the hunt, the post horn, sounds from the farm, and noise in the rural soundscape. And he looks at this idea that as human society has evolved from a largely rural to largely urban, some 10 to 12,000 years ago, the soundscape drastically changed and shifted. And he begins to look at other sounds, sounds of the city, religious sounds, sounds from clocks. He brings up an interesting term called keynote sounds, which he defines as those sounds that are heard by a particular society continuously that form a background against for other sounds. He also looks at the idea of sounds of day and sounds of night, sounds of horses and wagons, and rhythms of work and noise in the city. So these are kind of the first soundscapes in the world before it was industrialized. And then the next part of the book looks at the post-industrial soundscape. So the sounds of the Industrial Revolution and the sounds of the Electric Revolution. And so looking at the sounds of technology and really how they have changed and evolved over the last several hundred years, how, you know, in the 1700s, when different types of machinery were being invented and produced, the soundscape changed drastically again and looks at noise in factories and the conditions in factories, noise as power, and this idea of the flat line in sounds, of what that means. And looking at telephones and radios and music. He also had an interesting thought that he was interviewed, I think it was in the late, maybe late 2000s, early 2000s, I should say, and was asked about what he thought if he thought that we were in the noisiest time. He said no, actually he thought that like the 60s and the 70s were noisier than they are now. With the advent of muscle cars, muscle sounds, and very noisy airplanes, he actually thought that that time period was noisier than now, which is fairly interesting. And the next part, part 3, analysis, really starts getting at the core of his philosophy and how he begins to analyze and examine soundscapes. And so he has a section on notation, because if you think about it, sounds, you can't see them, we can just hear them. And so there's this idea of, well, what's the correct way to show sounds visually? How do we show sounds visually? And so goes into these different ways of notating sounds, sound images, and looking at 3D acoustic images. And he defines this idea of a sound object, which he considers the smallest self-contained particle of a soundscape, which is pretty interesting. He also starts to look at, how do we classify? How do we perceive sounds? And so began to look at different kinds of classification systems, and tried to classify sounds according to their physical characteristics and according to their perceptual characteristics, according to their function, you know, what use are they in our society, according to their meaning, and their emotional and affective attributes as well. How do they make us feel? Do they make us nervous? Do they make us happy? So very interesting. He talks about the idea of noise, and I mentioned he had a whole class that he did on noise. And you know, he describes the idea of noise, of having a definition that's constantly evolving. And I think that that's very true, because what is noise now may or may not have been noise in the past. What's noise to one person may be noise to someone else, but maybe music to someone else. And so of allowing the kind of fluidity of interpretation for noise is you know, a very important idea. He also goes into the effects and hazards of noise, of hearing loss and that kind of thing, of the public reaction to noise. How does the public perceive certain sounds? Do they like it? Do they not like it? Traffic is generally not liked. Sounds of nature is sometimes liked, depending on the context, these kinds of things. There's also an interesting bit about noise legislation and the history of noise legislation. And you can see on the screen we have here, the city of Bern in Switzerland has a number of bylaws going from the year 1628 all the way to the year 1967. And, apparently they're not really liking singing and shouting in the streets. They're not really liking barking dogs. They're not liking music on the streets. They're against noisy music, singing at Christmas and New Year's parties, and unnecessary cracking of whips at night in 1911. They also don't want carpet beating and mattress beating in the 1914s and 15s and noisy children. So we've got a number of different bylaws and legislation that you can see over the course of history as the sounds evolve and as people's attitudes towards sound and noise evolve. And, we tend to think of noise as a modern issue, but Murray Schafer informs us that back in 44 BC, Julius Caesar declared that no wheeled vehicles would be allowed from sunrise until the hour before dusk. And also in 117 AD, Juvenal says it's absolutely impossible to sleep anywhere in this city. The perpetual traffic of wagons is sufficient to wake the dead. So these are, some interesting observations that these sounds that wheeled vehicles made were a nuisance hundreds and hundreds of years ago. And nowadays, we still think that wheeled vehicles are a nuisance, but they just look a little different and function a little different than they did back then. He also looks at noise and language and taboo sounds. And part 4 is really where Murray Schafer starts to get into the idea of acoustic design and goes over these concepts such as listening, ear cleaning, and sound walks. And he has this really cool little sound map that he made during different types of listening walks or sound walks around the city with a little legend that shows whether the sound was a bird or a dog or a TV set or traffic. And so just an interesting way of starting to look at and think about sounds. Murray Schafer said that acoustic design is to regard the soundscape of the world as a huge musical composition that's unfolding ceaselessly around us. We are simultaneously its audience, its performers, and its composers. And so thinking about it this way, he asks us, which sounds do we want to preserve, encourage, and multiply? He also says that the acoustic designer must thoroughly understand the environment he's tackling. He must have training in acoustics, psychology, sociology, music, and a great deal more as the occasion demands. Lots of stuff that he believes. And he said, this is interesting, God was a first-rate acoustical engineer. He says that noise represents escaped energy. And he says that the perfect machine would be a silent machine where all energy is used efficiently. And so asks us to look at the human anatomy and consider that as the best machine that we know. He also looks at this idea of acoustic communities, of who are the users of the space? How is the space being used by them? If we tend to think about spaces, and if we are designing, sometimes we may think of just the users of the space, the people who are coming in to enjoy it, but there's also the staff there, people that may come in to do the odd job there, other visitors. And so there's typically a number of acoustic communities that are associated with the different spaces and environments that we look at. He also looks at this idea of rhythms and tempi in the natural soundscape and in radio broadcasting. And this is a really interesting idea that is kind of the foundation of some of the studies that we look at, because we have to understand that the soundscape is constantly changing from day to day, from day to night, from week to week, month to month, year to year. And understanding the rhythms of the space and understanding how they flow is very important in understanding the true soundscape of the space. So those are some of the principles that Murray Schafer looked at and explored in this very fascinating book of his that's so timeless. We're going to skip over now and take a quick look at the ISO standard, because ISO has provided a standard on soundscapes. It's ISO 12931. It's broken into 3 parts. And so part 1 really provides the definition and conceptual framework for soundscapes and explains the factors that are relevant for measuring and reporting in soundscape studies, and is kind of a springboard for the planning and design and management of soundscape. Part 2 is really focused on the data collection and reporting requirements. So it describes the idea of a sound walk, and it also provides instructions on how to perform them. It provides a list of questions of qualitative questions for participants and directives for the participants, and the number of times that these questions are conducted. It also looks at a taxonomy of sounds as a means of reporting and classifying the sound sources without a value judgment. And part 3 is really focused on the data analysis. And so the ISO standard is an interesting approach to quantifying and qualifying the soundscape. There are many other acoustic standards out there, and some of them provide very explicit instructions for taking acoustic measurements. Some are best practices to follow. Some have to do with the instrumentation, but most of those don't include human perception of sounds in the protocols, which is unique to this standard. So this standard, especially part 2, outlines some very detailed instructions on how to perform a soundscape assessment, perform sound walks, questions to ask participants in a questionnaire form, binaural sound recordings, and recordings of acoustic taxonomies to help provide a characterization of how the local users view their soundscape. And so this standard can be used as a tool to help understand how all of these various users view their own soundscape, how they understand which sound sources are the most pleasurable, which ones evoke stress, which ones are unwanted that should be reduced and mitigated, and which ones are wanted so that they can be preserved and enhanced, so that we can take the data that we get from this method, as well as other standards, and then transform it. We transform the data into the physical structures of the site or the building. And the data can become transformed into the acoustic interventions so that we can reduce the unwanted sounds, and so that we can create these special sonic moments where we have a distinct acoustic environment that's created purposefully to elicit a feeling or experience. And I think that's potentially what a lot of audio engineers do, creating these special sonic moments to elicit a certain response or feeling. So now we're going to take a look at a few case studies. The first case study is that of a natural soundscape. This is a beautiful park located in Florida that we had the opportunity to perform a very detailed soundscape study. And so in the soundscape study, we first went and listened with our ears, took some notebooks, but really we're just there to experience it. Then we made a list of the taxonomy of the sounds, of the human sounds and the natural sounds. And we also looked at the animal sounds. What kinds of animals were there? What sounds did they make? We also looked at weather sounds, the landscape sounds, other sounds of humans, more detailed sounds of humans and how they use the space. And transportation, lots of transportation, transporting people to and from this spot. And we began to explore this idea of itineraries. Itineraries are the routes along which the users inhabit this space. And the itineraries are composed of the users, and they're composed of all the sounds that the users make along their paths. And so the kayakers and canoers had a certain itinerary where they used certain areas of this park. And the hikers also, however, their itinerary was a little different than the kayakers and canoers. The swimmers also inhabited different areas of the park, and as did the picnickers, finding their picnic tables and eating with their families and friends. And the park rangers, they inhabited different areas of the park as well. And we started to look at this idea of acoustic rooms. So an acoustic room is a little different from a traditional room. A traditional room has got walls and a ceiling and floor. An acoustic room doesn't always have those physical attributes. And so the acoustic room is defined by the physical characteristics of the space, but also the sound made from within the room. So when we start to look at this, we can start to identify some acoustic rooms in this park. This was one acoustic room, the acoustic river, or the open river acoustic room, where in this area, the landscape was largely very similar. And so this one area could be considered one acoustic room. We started to identify other acoustic rooms, some man-made, some natural, all along the park, so that we can start to identify areas where the sounds that are produced within these areas are similar and have similar acoustic attributes. And so if we think about acoustic rooms in this kind of sense, we can also measure them. And so we devised a measurement technique where we used impulse responses to measure these outdoor spaces. We used a balloon as the sound source and an audio recorder and took measurements along paths, in the kayaks and along different areas. And we were able to measure these spaces just like you could in a traditional room. And what we saw was that in areas where the river was more open, they had a much different acoustic response to the areas where there were these limestone walls that formed caves and partial caves around them. So we could look at the impulse response of these rooms, and we could derive acoustic measurements from them and acoustic metrics. So like this open river acoustic room had a nice short reverberation time of 0.11 seconds. And as I mentioned before, Murray Schafer looked at this idea of rhythm and tempi in his book. And he says, we would observe an infinitely complex series of oscillations as each activity rises and falls from exertion to slumber, from life to death. And he also says the environment contains many sets of rhythms, those dividing day from night, sun from moon, summer from winter. And so keeping this in mind, we took long-term measurements outside for 24-hour time periods. And we can look at how do the sound levels and frequencies change from day to night. We can see here in the middle where the nighttime is, the sound levels go up. Whoops. Sound levels go up. It's actually due to cicadas, not crickets. Cicadas can be very, very loud. And in certain times of the year, they're very, very active. So taking this kind of data for days at a time during the different seasons, we can see how the sound levels change over time. But the top was taken during the fall. The bottom was taken during winter. As you can see in the fall, sorry, that's somehow on a timer. The sound levels during the nighttime, which is shown here in the middle, are high because of the cicadas that I mentioned. But when it gets a little too cold for them down in February, whoops, the sound levels go down to what would be an ambient sound level without those cicadas, so much, much lower, into the 20s decibels. And looking at this is a hypothesized seasonal acoustic calendar of the different types of sounds that are heard. So some are going to be consistent throughout the year, and some are going to vary as birds migrate, as insects die off, as amphibians are not as active. And so, with these kinds of things, we're able to sort of visualize the change and flow of the rhythms of these spaces. We can also begin to look at a really detailed taxonomy and acoustic calendar that kind of combined. These are all of the birds that inhabit this space. And, this kind of taxonomy could be done for any of the species of animals that inhabit these areas. And so just an interesting way to kind of consider the complexity of the soundscape, at least in these natural settings. An important component of what we do as acoustic designers is modeling spaces so that we can predict them. And so we look at, well, how would we model an outdoor space? What would that look like, and how would that react? So we started out by creating a large absorbent box and putting in the tree trunks and vegetation inside so that we could actually look at what an impulse response might be in the woods. We also did another series of models looking at the effects of different types of sound sources across the park. This is from automobile noise. So we can see very intense levels along the roadways. And then taking those sound levels out and just looking at the human generated noise, the noise of people walking along the trails, of people going down the river, much less intense. And the same with natural sounds, the bird sounds, the insect sounds. So compared with the roadway sounds, much different. We can also take these models and look very specifically at areas close up. So we can look at, what a leaf blower might do on the site, what footsteps or a tram taking people to and from these areas might sound like. And it begins to show us on a micro scale how localized sound sources propagate on the site. Now we're going to switch gears and go inside for a look at how the soundscape method might be used inside. So we're going to examine a little bit about restaurants. Restaurants right now are kind of a hot topic, and restaurant noise is something that seems impossible to fix, but it's not. But we're going to go through a series of slides to look at how we did soundscape analyses for restaurants. So the idea of restoring while dining out. When we go to dine with our family, with our friends, we're there to have an experience. We're there to not only share a meal, but to be able to converse. I mean, that's typically the main reason that we go somewhere, so that we can have a conversation, so that we can communicate with the people that we care about, with the people that we love, with the people that we're making business deals with. And so understanding that the communication is really at the core of what the dining experience is all about. So when we look at restaurants, we tend to see three main acoustic communities: the patrons, the wait staff, and the food preparers. And as we begin to think about the acoustic communities, we can look at specific taxonomies of how the acoustic communities use the space and what types of spaces or what types of sounds are heard within the spaces. So forming the taxonomy allows us to understand that at a much deeper level. We can also begin to look at what we have here, the itinerary. The itinerary of the various users when they're using the spaces. They go in different areas, they use the spaces differently than each other. And so by identifying some of these itineraries, we can really start to understand how different parts of the building are used and who uses them, what sounds are being made where and why. Next, looking at acoustic rooms in restaurants is a little different than in the natural environment. Acoustic rooms in restaurants are more typically defined by at least some kind of surface, whether it's the walls, floor, ceiling, part height dividers. And each room looks a little different. Some may be large and open with large volumes, such as these, and others may be smaller, quiet nooks, such as these. When we think about acoustic measurements in a restaurant, we also want to think about the communication paths, because when we take measurements in a restaurant, we think it's important to take measurements that simulate how the space is actually being used. So this means using sound sources located in places where a sound source might actually be not in some location where nobody will ever sit or stand. And we think the receiver should be in places where people will actually sit, well, they'll actually hear sounds. This allows us to identify specific communication paths and to understand which areas are have good communication paths and which have not so good communication paths. Because when we look at these, so when you look at this series of diagrams here, communication paths across a table are usually the ones that you want to preserve and enhance. They're the ones that people care about. I want to hear what the waiter's saying. I want to hear what my husband and my children are saying to me. I don't necessarily want to hear what everybody else in the room is saying. That's not helpful to me. And when that happens, it creates unnecessary loudness and excessive reverberation. I only want to hear my sounds and the sounds that are important to me. And when we start to look at it this way, we realize there's actually a pretty complex interaction of all of these different communication paths in buildings. And whether it's a restaurant or a library or an office building or a school, these communication paths are crucial to understanding how people use the rooms and what we can do to help them. And so looking at this idea, putting it into a practical context, I want to show the case study of this tavern in Florida. We had a fairly open restaurant that was receiving all kinds of complaints about excessive noise, excessive reverberation in it. And so we went and set up, took acoustic measurements in the room using multiple source and receiver locations. But in this particular instance, we had the source facing the bar area and the receiver in the next dining area over. And we looked at the impulse response so that we could diagnose where harsh reflections were coming from. And we looked at the reverberation time. So this had a reverberation time of a 1.3 to 1.5 in the middle frequencies. So by doing these kinds of measurements, we're able to analyze which surfaces are going to be the most beneficial to treat and why, so that we can begin to look at what acoustic interventions might be needed in this space. And this is kind of at the heart of what we do. We help diagnose spaces and help to determine what kinds of absorbent material, diffusing material, reflecting material needs to be put where, how much, why. And so, we're able to identify these surfaces and which ones are going to be the most effective, which ones aren't, and be able to provide recommendations on what needs to go where, so that ultimately we can help the acoustic environment in these spaces. So interestingly enough, same kind of technique, different room, different client, different ideas about possible treatments. As you can see in this room, it's a very recent room. It was done maybe a year or so ago, and it opened up and there were just major issues with it. Very, very loud, people complaining constantly. They shut the restaurant down because it was so bad. But this particular client was very intent on keeping this pretty ceiling to the extent possible. They were very partial to it. They worked really hard on the design with the interior designer and didn't want to mess with the ceiling. So, doing the same kind of analysis, taking acoustic measurements and looking at the room, we found that the ceiling was producing a lot of these harsh reflections. But if the client doesn't want to treat the ceiling, then we have to adjust our recommendations to try to have the client get to a place where they can put other treatment in, and if needed, go to the ceiling. And so that's what we did. We gave them a series of prioritized areas to treat first on the walls, and with the caveat that they treat the space, but because we're not treating the ceiling, there still could be a number of acoustic issues in the room. So if it comes to the point of them doing the treatment and finding that they still were having issues, to consider, even though they didn't want to, several options for treating the ceiling, whether it's option A was just a full treatment on in the middle area of the room as a priority 2, or whether it's some kind of slatted blades, or whether it's some kind of shapes, in case the acoustic environment still wasn't satisfactory. And so, taking some of these ideas and translating them into a kind of practical real world applications is what we're looking at. Because ultimately in restaurants and in other spaces, we are hoping to design sonic niches where, using architectural elements, we can have either semi or fully enclosed areas, full or part height walls, and even customized music in some of these areas, so that we can provide these really special spaces for communicating and dining. So that wraps up those case studies. Now we're going to kind of look at how does this all tie in together. And for that, we're going to look at a case study of the Kimball Art Museum and look at how the ideas from Murray Schafer influence these kind of underlying philosophical principles for relating acoustic design and the environment. So we're going to start off with this case study, as I mentioned, where we're going to look at 5 levels of research that can affect the architectural, urban, landscape, and natural areas. So these involve inspiration, planning, conceptual structure, tectonics, and detail. So when we think about inspiration for a space or an environment, it typically starts with the architect. The architect has to be inspired. So before any drawings are ever drawn, before even the pen goes to paper, you have to sit and dream about the inspiration. And Louis Kahn wrote that this was his idea of a museum: silence to light, light to silence. The threshold of their crossing is the singularity, is inspiration, where the desire to express meets the possible. Is the sanctuary of art, is the treasury of shadows. And so this idea to him of a museum is light and silence. It's very abstract, right? It's not concrete at all. And then it has to transform. And so, we're thinking about our space in poetic terms. So this idea that sound can inspire architects, can inspire designers, can inspire anyone on their projects. This is a level that people don't necessarily think about. But to be able to think poetically about these sonic moments that we're trying to create is really at the crux of the very beginning stages of what we look to do. So this helps to provide insights early in the project to help guide the design. The next stage is planning. And so in this case study, Louis Kahn says that he would like the entrance of the trees is the entrance on foot, which links Camp Bowie Boulevard and West Lancaster Avenue. 2 open porticos mark the entrance court of terraces. In front of each portico is a reflecting pool, which drops its water in a continuous sheet, about 70 feet long in a basin, 2 feet below. And so you can see with this quote and in this idea, now the structure is starting to take shape, and he's starting to think about what this might look like with the reflecting pools, with a continuous sheet of water, where he also says the sound would be quite gentle. We have these nice reflecting pools, but they're there for a reason. They're there to help drown out the sounds of the traffic on the busy road in Fort Worth. And the next is this idea of conceptual structure. Structure is the giver of sound. Because of the open porches, how the building is made completely clear before you enter the building. So the idea of the structure of the building, how it's built, what is it made of? These things start to become more tangible in the design process. And the structure of the building is also going to color the sounds that are heard in it. Structure gives way to the tectonics. The tectonics are really the way that the building is framed and put together. So we have all of these vaults that you can see in the Louis Kahn Kimball Art Museum. And these vaults are made of concrete. The vaults give this space its sounds. And the next is the detail. Louis Kahn says, I put the glass between the members which are structure and the members which are not of structure, because the joint is the beginning of ornament. Ornament is the adoration of the joint. And so this idea where we've got this little piece of glass coming to separate the structure from the infill. And in projects, this is really where a lot of the work that we think about is involved. It's in the details of the project. It's in the finishes of the project in the space. It's in the speakers. It's in the placement of the speakers and the aiming of them. The details are the way that all of the core philosophical components come to life in the project. And so when you think about this as a process, we can look at it as potentially a linear approach, where, we start off identifying acoustic communities and looking at the different relationships, developing taxonomies and whatnot, looking at acoustic rooms and mapping itineraries, looking at calendars, but really the approach is not linear. It can really be thought of in a few different ways. So part of it is scientific, part of it is artistic and interpretive, part of it is creative with design, and then it goes back to scientific. So when we begin to look at this idea of the science, this is where a lot of the ideas of Murray Schafer really come in, of documenting the sounds and the itineraries, of looking at the rhythms and tempi in the spaces and understanding them. And this is where the ISO standard really comes in, is trying to look at the scientific aspect of it. But then there's a whole other part of it where we have to take the scientific information, we have to take the data, and we have to interpret it artistically. How does the data, how does the information somehow become the structure in these environments, in these rooms? How does it become an experience? And so this whole idea of looking at the creative design process as an assimilation of the science and then of data gathering to this artistic creative expression, and then how it's all related, looking at this idea of feedback loops throughout this entire process, of through each stage, whether it's the scientific stage, we can come back, and when we transform, we need to get feedback. We need to get feedback from all of these different processes so that we're constantly reframing and adjusting what we're doing to be continuously learning and evolving throughout this whole process. And so, this is really at the heart of what we do, at the heart of how we analyze, and likely the kinds of challenge that you and that I deal with on a day-to-day basis. So, when we think about soundscape is a term that was loosely defined by Murray Schafer as being a kind of composition, a musical composition of many different players. And if you can allow the definition to remain fluid, then it can begin to represent so many attributes in our sonic world. And by using some or all of the different soundscape elements that were outlined in this presentation, you can use these tools to try to better understand the sonic environment and use this understanding to very purposefully create the soundscapes around us. You can have a soundscape that is created by chance, that is just the result of a building is built and it has all of its infrastructure and the sounds of how it's used, and it's just a kind of haphazard byproduct of civilization. That's one way that a soundscape can exist, and that happens all the time. But the soundscape can be very carefully crafted. It can involve a series of acoustic interventions that can enhance and preserve the desired sounds and the desired sound paths. It can begin to mitigate and buffer unwanted sounds, and it can create new sounds to enhance the architectural and acoustic environments. And so, really what I want to impress upon you is just, there's this constant dialogue between art and science and buildings and the environment. When you're an architect, you have to understand the technology of your craft, but then understanding the technology of your craft is one thing, but then transforming it into a unique experience in each of your projects is a completely different thing. And as a soundscape designer, as an audio engineer, each of your projects is going to have its own unique acoustic identity. And you're going to have to work with your clients to create that for every project. And so this transformation of the data, of the raw scientific analysis to the art of what our buildings and environments become is at the heart of what we look at. You can have, 5 different restaurants or 5 different concert halls, and they could all have the same reverberation time. They could all have very similar acoustic criteria, but the oral experience in each one is going to be completely different. The architecture is going to be completely different. How it looks is going to be completely different. And so, just understanding that there is this constant dialogue between science and art, and this interplay is at the root of what we do. And so I want to thank you for your time and hope that, this presentation gives you a little bit to think about and helps you understand a little bit of kind of what I do as an acoustic consultant, but hopefully can help you think about some of the projects that you work on and, think about this challenge that you have, I'm sure, of wrestling with science and art and bringing them together and transforming them for all of your projects. So with that, I want to conclude the presentation, and I guess we can open it up for questions or discussion or however we'd like to do it.